Hey everybody, my name is Scott, and today we're going to solve the degree of an array problem on LeetCode. The problem definition is, given a non-empty array of non-negative integers, the degree of this array is defined as the maximum frequency of any one of its elements. What we need to do is find the smallest possible length of a contiguous subarray of nums that has the same degree as nums. So let's look at the example. What's the degree of this array right here? Well, it'd be 2, right? Because 2 occurs twice. Ignore the fact that the number occurring twice is 2. It's the maximum frequency of one of its elements. And we have an element here that appears 2 times. And what do we output? 2. Because the degree of this entire array is 2. However, there's a subarray right here, 2, 2, that is also of degree 2, which is of length 2. There's way too many 2's in that example. It said 2 over and over again. It gets a little confusing. So, this example, what's the degree of this array? The degree of this array would be 3, right? Because we have 2 occurring 3 times. So, what's the subarray that also has a degree of 3? Well, we need something that has an element occurring 3 times in it. Well, the 2's occur 3 times. Those are the only ones. So 1, 2, 3, 4, 5, 6. So this subarray, chopping off the 1, is of length 6, and it also has degree 2. So that's what we're going to do. And here's how we're going to do it. We're going to keep track of the counts of each element and their indices from left and right. And the reason we can do that is if we have an element that occurs the same number of times as the degree of the entire array, then we can compute the size of that subarray that has that degree by taking its right index, subtracting away its left index of the first time that element occurs, and plus 1 to that. So this example right here, we find that the array has degree 3, and then we look at each element. Well, we don't really care about the 1's, they only have 2, that's not of degree 3. And then we see the 2's, well there's 3 2's. The first 2 happens at index 1. The second 2 happens at index, I believe, 7. Right? 1, 2, 3, 4, 5, 6, 7. At index 6. So from index 1 to index 6, 6 minus 1, 5, plus 1, 6. So that's how we compute the size of the subarray. So let's implement it. We need 3 hash maps, all from integer to integer. First one will be called counts. I believe I typed that one out right. I'm going to copy and paste this guy 3 times. 2 more times. And we're going to rename these guys left indices, right indices. Alright, so in counts we'll keep track of the count of each element. Left indices will keep track of the first index of each element where we see it from the left. And then right indices will keep track of each element the last time we see it on the right of the array. So we're going to loop through the array. And we're going to update the counts. We're going to update the left and right indices as we see things. So if our left indices does not have the key nums of I, so if we haven't already found the leftmost index of this element, then we need to add it. So we'll put into our left indices the element and the index that we see it at first. And we're always going to put it into the right indices. And why are we always putting it into the right indices? Because each time we see it as we're scanning from left to right, then this is the rightmost index that we've seen each time. So we'll just keep updating that. And in here, we're just going to update the count of everything. If you've already seen it, then we will update it to be +1 of what we already have in there. If we have not already seen it, then we'll just put 1 in there. Make sure this guy says nums. Alright, so we loop through the array once, we update the counts and the left and right indices of each element. Now we're going to initialize our answer to be nums.length, because the length of the subarray of the degree of the entire array at the beginning we can always say is at least the length of the array. Now the degree of the array is going to be the maximum of the counts elements. So we have the degree. So for each element that we have seen, we are going to see if it has the same degree. And what do we do if it does? Then the answer becomes the minimum of answer, and then we compute the subarray size of this element, which will be its rightmost index minus its leftmost index plus 1. That'll do it. Let's make sure everything looks good. Probably a typo here or there. Did I misspell indices? A tricky little word. Looks like we got the right answer. Submit it and see what happens. Accepted. Alright. Interesting little problem. Guess what we can take from this is hash maps are big when we're trying to count things. If you got to go through an array, you've got to count things, keep track of how many times you've seen things, keep track of where you've seen things like we did with the right and left indices here. Hash maps are always good because it lets you look up that information in constant time. So that is it for this video. Hopefully you learned something, and we'll see you next time.